Okay, so the last thing we're going to look at is if we have radical problems, but they're written in exponential form. So there's actually two ways to go about this. I'm going to show you a new way first, and then we'll remind you that there's an old way to handle it as well. So regardless of which way you're doing this problem, the first thing that needs to happen is you need to lose the 2 on each side, because that's not a part of the exponential expression. So really my job is to solve this equation. So 2x, the quantity 2x to the 3/4 equals 8. So a way that you can get around this is you can raise both sides to the reciprocal power. So if we had 3/4, we can raise both sides to the 4/3 power. And then what happens is 4/3 times 3/4 just becomes 1. So if you want to just cross them out, feel free. That leaves you with 2x on this side. And then if you do 8 to the 4/3, the cubic root of 8 is 2, and 2 to the 4th gets you 16. So then I'm getting 8. Now here's where you got to be careful. This was a quartic problem. So if you were to turn this into a root, you would have had a 4th root. That is an even index. So you technically still have to check your answer. If you're not sure, always check your answers. But it should, for this one, you would have to check because this could be extraneous. It's going to work just to save you on time, but keep that in mind. This would have been the old way of doing the problem, so you guys would have changed this into the quartic root of the quantity 2x cubed. So again, I'm going to lose my 2 on each side and change that to 8. And then I'm going to remove the root first by raising both sides to the 4th power. And when you square or raise to a 4th or a 6th power, that's your hint. Oh shoot, I gotta check for extraneous solutions. Then I have the quantity 2x cubed. That needs taken care of, so I'm going to cube root both sides. And the cubed root of 4096 is 16, and I still get 8. So whichever method you're comfortable with, it's totally up to you. This tends to save you on some hassle during certain times. So for one of these down here, fairly simple problem. I'm going to try it the new way. This is all to the 1/2, so I'm going to square both sides. And I'm going to get x plus 30 equals x squared. And then I'm going to solve it like a normal quadratic. And once again, it factors nice and pretty for you. So you get 6 and -5. And that should be an x, not a 0. You'll find that if you put -5 into this problem, it's not going to work. So that's an extraneous solution. The only answer is 6. The next problem, I actually borrowed this from one of your throwbacks. So the first thing I'm going to do is I'm going to add 6 to both sides. And then I'm going to divide the -5 over. So I have 1024 equals all of this to the 5/3. Now, on your throwback, you probably did the cubed root of all this to the 5th power, which is fine. It's just going to be some big numbers to work with. So I'm going to be a little lazy, and I'm going to raise both sides to the 3/5 power.